All right. All right, in reteaching learning target 1 and 2, I wanted to open up with a few questions that didn't even really involve fundamental counting principle or permutations and combinations, just counting things to see how they do relate to counting things in general. Like for starters, number 1 here, how many outcomes are possible when you flip a quarter and a nickel? Well, you could get heads on the quarter, heads on the nickel. You could get heads on the quarter and tails on the nickel. You could get tails on the quarter and tails on the nickel. And you could get tails on the quarter and heads on the nickel. Is there anything else you could get? No, that's all 4 possible outcomes. Then in number 2, we're flipping a quarter, a nickel, and a dime. How many outcomes could you get there? Well, you could get heads, heads, heads. I'll be systematic about it. Heads, heads, tails. Heads, tails, heads. And only one more option with the heads on the quarter, but the heads on the first option. Heads, tails, tails. That covers all of the heads first, right? Now the tails. Tails on all 3 coins. Or tails, tails, heads. Tails, heads, tails. And last one, tails, heads, heads. For a total of 8 outcomes. Now I want to kind of bring the fundamental counting principle in at this point. But these are making sense because you can see them, right? Well, the fundamental counting principle says this: if you're going to flip a quarter and it has 2 options to land, and a nickel and it has 2 options, then you multiply 2 times 2, and there are 4 options when you have a quarter and a nickel being flipped. Same thing for number 2. When you have a quarter, a nickel, and a dime, well, all 3 of those items are 3 different events, and they can happen 2 ways, 2 ways, 2 ways. So it's 2 times 2 times 2. You get 8. So just before we even list number 3 or look at them, how many outcomes would the fundamental counting principle say you're going to have when you roll a pair of standard 6-sided die? One die has 6 options. The other one has 6 options. So you're going to have how many options? 36. 6 times 6. And now the Excel file we've been using, here are those 36 options. 1 and a 1, a 2 and a 1, a 3 and a 1, a 4 and a 1, a blah, blah, blah. Sometimes the probabilities that we've been working with ask us things about your sums when you roll these 2 die. So there's a list of all of the sums you get for those outcomes. And sometimes they even ask about the products that you get when you roll 2 die. But there's still 36 outcomes. Does that make sense? All right. So 36. So use the fundamental counting principle to answer number 4, or just think about the things that you could get when you roll a standard die and spin this spinner. How many did you get? Still thinking? How about this? Let's think about this. What's one outcome you could get? A 6 and yellow. A 6 yellow. All right, good. What else could you get? A 6 red, a 6 blue, a 6 green. Okay. You could also get a 5 yellow, 5 blue, 5 green, 5 blah, blah, blah. It's 6 times 4, isn't it? That's the fundamental counting principle. 6 times 4. There's 24 of them. I could even ask on the quiz tomorrow things about this set. So let me pull up a blank page. We just said that you would have outcomes of 1 red, 1 blue, 1 green, 1 yellow. 2 red, 2 blue, 2 green, 2 yellow, etc. 24 of them, right? I could ask you to find the probability of getting an even or red. And that's a learning target 5 question. Because those are non-mutually exclusive events. Here's an example of getting a red that has an even number, but it's also red, right? So just because we've been using the number dice, the standard 6-sided dice, doesn't mean that's the only thing we could use for those questions. All right, so keep that in mind. All right, going back to learning target 1 and 2, the reason we're learning these, a reason that we're reteaching this. The first 4 examples we could visualize. The last ones you can't really visualize because the answer's so big, it's like, it would take you forever to list them all out. So you just got to trust the method. So number 5, how many 7-digit telephone numbers are possible if the first number cannot be 0 or 1? Well, how many events? Events are things you're choosing, like rolling the die, spinning the spinner. How many things are you going to choose when you make a 7-digit phone number? You're going to choose 7 different digits. 1, 2, 3, 4, 5, 6. There are 7 events. How many ways can you choose the first digit according to this problem? Careful. How many digits are there in the world, in the number world? There are 10 digits. This problem says you can't use 0 or 1. So there are 8 options. All right. When you go, so 753, that's Murray, right? 753. We just chose the 7. Now choose the 5. How many options do we have to pick from to choose the number 5? Back to 10. Because it doesn't say you can't use 0 or 1 on the second digit, so you got 10 options, and then you got 10 options again, and then 10 again, and 10 again, and 10 and again. All right. Multiply all those together, and you get 8 with 6 zeros, so 8 million. That was independent because it didn't say anything about not being able to use the same number again. So try the next one, because it tells you can't use the same number again. Still a 7-digit phone number. This one's kind of tricky, so be careful. 753. How many choices do you have when you say 7? Close. Really close. Really close. Close. You're all close. And you're all right with this number right here. As I walk around, I'm seeing the 8 there, but I'm not seeing what I need to see in the next spot because you got to slow down here and think. 753. You just chose 7. Okay, we chose 7. Now we're sitting here thinking about the next number in this telephone. And we need to think about how many options we have to pick from. We had 10 before, but now we have 9 because we just used the number 7. So there are 9 choices for the second digit. Not 7, not 10. You know, I can see how you can go in those different directions, but just be careful. So then after that, choosing the 7, 5, how many you have left? Yeah, now you got it. 8, 7, 6, 5, 4. And the answer you get when you multiply those is 483,840. You can see why these are examples that you've got to just trust the method. Are you going to list out all 483,840 telephone numbers? No. So you have to trust it. All right, try 7, 8, 9 on your own. I'm just going to put the answers up here, and if you need to talk about any of them, I'll talk about them with you. But I'll give you a minute. I'll pause the video here. All right, as you can see on the video, we already answered 7 and 8. The letters are 26 options. Numbers, there's 10 options. And in number 7, you can repeat. In number 8, you cannot repeat. So that changes how many choices you have once you use them. We haven't talked about it yet, but independent versus dependent, that's exactly what this is. Independent choices mean that the one that you chose first doesn't affect the one you choose second. There's no relationship. However, when you pick a number or a license plate letter and it says you can't repeat, you can't use that letter again. That's the dependent choice. All right, so the last one. The answer is not 40. Not 40. Now, the way you get 40 is 10 times 4. Now, if we think about the fundamental counting principle, if you say that it is 10 times 4, and I'm going to erase this, here's what you're saying. Pick a question, pick a letter. You're saying the events, that there are 2 events. Event 1, pick one of the 10 questions. Event 2, pick one of the 4 letters. Is that really what you're doing when you answer a 10-question test? Or are you answering 10 questions? Aren't you answering all 10 questions when you take this test for real? Then there aren't 2 events. There are 10 events. 10 events. Because it's a 10-question test. If you were sitting there at your desk and I gave you a 10-question test and told you to answer it, you'd probably do something like, A, B, C, D, A, B, C, D, A, B. But if we analyze that, your choice for the first answer was A. How many did you have to choose from? 4. Your choice for the second answer in that example I just made up was B. But how many choices did you have? And I think you're already seeing the pattern, right? It's 4 times 4 times 4 times 4 times 4 times 4, which can be shortcutted. Shortcut, I'm not sure exactly if I said that right. That's 4 to the 10th, and that gives you 1,048,576. All right, I'm going to stop the video here.